Hello everyone, this is Ma'am Amano, and this lecture video is all about sigma notation and its particular use in representing a series. So, first let us define series. It represents the sum of the terms of a sequence. So, for example here, 4 plus 5 plus 6 plus 7 plus 8. Then this one is a series and the sum of these terms is 30, right? So, that is what we mean by sum of the series. Then we have two types of series, that is finite and infinite series. For example, I have here a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub n. If you want to get the sum of this all of the series until the sub n, then this one is an infinite series. Okay, so this is typically used in physical computing in the computers. This one is infinite if you want to get the sum until the a sub n, and this one is finite series if you just want to get the partial sum. Then I have here the sigma notation. It is used to describe the sum of the terms of a sequence. It is also known as summation notation and is represented by Greek letter sigma. This is the capital of that, used to represent the summation. Let us proceed on parts. I have here the sigma notation. This one is the last value or the upper limit. This is the lower limit. This is the index of summation, and then this is the formula for the terms. Another example of the parts, I have here again upper limit or the last value of the variable here, which can be represented in different letters. Then formula for the terms, the Greek sigma that represents the summation, the lower limit or the index summation, first value of the index. Another one here, this one, the last term or the upper limit is 5. The capital meaning, which is the summation, and then this is our index of summation or lower limit, which is 1, or the first term in the sequence. Then this is the algebraic expression inside the brackets, tells us what we do with each term of the sequence. This is your expressions. Alright. Since this is summation, this is all about adding each variable or component. Again, this is your upper limit. This is your lower limit or index of summation, and this is your variable or algebraic expression that you will be performing in an operation. So, for example, I have here the sum of the n plus 3 between 1 and 5 inclusive. That is how you read this. The sum of n plus 3 for n between 1 and 5. You will mention first the lower limit, then next is the upper limit. So how do we solve this one? So again, this is the expression that you will be using. So you just have to substitute. You will start with 1 since that is your lower limit, and then you will end or you will stop in substituting in 5 since that is your upper limit or largest number in the value of n. So let us start with the sequence with 1. Substitute 1 plus 3. Then next plus, since that is summation, you just have to add plus. Then the next for 1 is 2. 2 plus 3, then plus 3 plus 3, plus 4 plus 3, plus 5 plus 3, the last limit here or the upper limit, the maximum limit. That's how you perform the summation on that. And then simplify. 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6, 4 plus 3 is 7, 5 plus 3 is 8, add, that is 30. So therefore, the answer on the summation is 30. So you just have to again substitute the values here in the given variables in the expression here. You will start again with the lower limit, let us say 1. But if your lower limit is 3, you will start with 3. Since we have here 1, you will start at 1 and you will stop at 5. Let us say you have 7 here instead of 5, then you will stop at 7. Now let us proceed on more examples on writing and evaluating sums in summation notation. For example 1, write the terms of the following series and find the values of the expression. This one, the sum of the 4n minus 5, 4n between 1 and 3. That is how you read that. So the first thing that you need to do is write the terms of the following series and find the values of the expression. So you just have to write this series, the series of this expression. To write the series, you have to expand. So this is your algebraic expression. 4n minus 5, your lower limit or your first value for the first sequence in the value of n, substitution is 1, and the last number is 3. So that is 4 times 1 minus 5. Next is plus 4 times 2 minus 5, and then the last limit is 3. 4 times 3 minus 5. And then simplify. 4 times 1 is 4 minus 5. 4 times 2 is 8 minus 5. 4 times 3 is 12 minus 5. And then simplify again. 4 minus 5 is negative 1. Plus 8 minus 5 is 3. Plus 12 minus 5 is 7. Then the answer to that is 9. Therefore, the answer on this one is 9. Another example, for example, to evaluate this expression of the summation, this you can read this as the sum of negative 1 raised to n and 2n over n plus 1 for n between 1 and 5. So how do you do this one? You just have to expand. Okay, you will start with 1 on the substitution for n. You will end with 5 as your upper limit. So let us start. So negative 1 raised to n, which is 1, lower limit. Then substitute for 1 in all the n here variables. You just have to substitute 1 that. So 2 raised to 1 over n plus 1, 1 plus 1 plus negative 1 raised to 2. Second, this is an ascending order when it comes to addition until you reach the upper limit. So 2 raised to 2 over 2 plus 1. Then we have 3 next, negative 1 raised to 3. Then 2 raised to 3 over 3 plus 1 plus negative 1 raised to 4, 2 raised to 4, 4 plus 1 plus. Then you will have your last limit, negative 1 raised to 5, 2 raised to 5, 5 plus 1. Then simplify that, you will have this value, negative 1. Okay, negative 1 raised to 1 is negative 1. That is alternating. And then negative 1 raised to 3 is negative 1. Negative 1 raised to 4 is positive 1. Negative 1 raised to 5 is negative 1. And then you have here 2 raised to 1, that is 2. 2 raised to 2 is 4. 2 raised to 3 is 8. 2 raised to 4 is 16. 1. Then substitute for the denominator. You will have this value here, negative 1 plus 4 third. You just have to simplify each. Simplify. You will have negative 19.5 or negative 3 for fifth. Now, for example 3, I want you to write the series in sigma notation, 2 plus 4 plus 6 plus 8 plus 10. The first thing that you need to do is identify the formula for the nth term of the series. So, you have to observe the successive number here. As you can see, these are all even number. We know that even numbers are all multiples of 2 and can be represented as 2n. Okay? And since you have here 1, 2, 3, 4, 5 variations of that, and that is 5, your upper limit. And then your lower limit is always 1 here. On this case, you will start with that. Since if you will solve this, that is 2 times 1, that will be 2. So your n would be 1. And you need to multiply that into to yield the same values here. So therefore, if you will expand that, you will still yield the same answer as here. For example, 4, write the series in sigma notation. 1 minus 1 half plus 1 third minus 1 fourth plus negative 1 over 10. Okay, the first thing that you need to do is to identify the formula for the nth term of the series. Since the terms of the series have alternating signs, use powers of negative 1. You have to use the powers of negative 1. Okay, here you will have that. Because any even power of negative 1 is positive and any odd power of negative 1 is negative. You have to use negative 1 here, n plus 1 over n. If you will solve that, you will yield these answers here. Properties of sigma notation. I have here the first property, property 1. If you will encounter this variation here, and this is the example for this one, this is the example. Okay, this is the format that it resembles this one. So all you need to do is multiply the variation here or the algebraic expression or the operation and then to its upper limit. So that is 3 times 4 and that is 12. Or you have to add this into 4 times 3 plus 3 plus 3 plus 3, that is 12. Same answer. Another property I have here, this one. So the thing that you need to do is substitution only. The a sub I here represents the index of summation here. So all you need to do is 3 times 1 plus 3 times 2. Your upper limit, this is your example anyway. This one. So you just have to substitute until you reach the upper limit, 3 substitution of 4. And then 1 plus 2 plus 3 plus 4, that is 10. 3 times 10 is 30. Or it can be represented such as this way. 3 its coefficient here, and then the a sub I represents the index of summation until it reached the 4. So you just have to add the index of summations, 1 plus 2 plus 3 plus 4, and then that will be 10, and then 10 multiplied to 3, that is 30 as well. Then another property, I have this one. So a sub I plus b sub I, the a and b represents the coefficients or the values. So I have here this example for this format. All you need to do is expand that, so that will be 4i plus 5. Same upper limit. Alright, so the next thing that you need to do is this one. Since this 1, 3, 5 resembles the summation 1, Cn, you just have to multiply the 5 and 3 plus 5 and 3 because it resembles the summation 1. And then for this one, you just have to substitute 4i. So that is the same case such as this one, 4i. This one. So you will have here 4 multiplied to 1 plus 2 plus 3. Since 3 is your upper limit, then that will be 6. 4 times 6 plus 5 times 3, that will be 15. Then 24 plus 15 is 39. Another example I have here, this one, and is equivalent to the index of summation here. If you encountered something like this, wherein this is the example, wherein you only have the summation index here, index of summation rather, all you need to do is expand that into this formula or this one. So that is, for example, I have here k open bracket 5. This is your upper limit or your n multiplied to the upper limit, which is 5 plus 1. And then over 2. If you encountered a variation wherein you have the I as your algebraic expression here. And then simplify. 5 plus 1 is 6. Then 5 times 6 is 30. Over 2, 30 over 2 is 15. Okay, if you encounter the form such as this one, wherein the algebraic expression is I, such as this one, you just have to expand that into this format. And then property 5, I have here n. The upper limit is n, but then as you can see, the algebraic expression here is in I raised to 2. So if you encounter that, all you need to do is expand that into this format, wherein you just have to substitute the n for its upper limit, okay, instead of the I, okay, if you encounter this one. Okay, so for example, they have the same format, right? You will expand it here. So, substitution, 7, 7, lahat ng n dyan, lagyan mo ng 7 plus 1, 2 raised to 7 plus 1, then perform the operation. 7 plus 1 is 8, 14 plus 1, it is 15 over 6. You will have this value, 140. And then if you encounter this formula wherein your algebraic expression is expressed as I raised to 3, then you have to expand that into this format. N squared, parenthesis n plus 1 squared over 4. So that will be, substitute the upper limit on each n instead of I, because you have here this expression as an example. Okay, so substitution, your upper limit is 5. Substitute that in all of the n values here over 4. Then perform 25, 5 squared, that is 25. Then 5 plus 1, 6 squared, that is 36. 25 times 36 is 900 over 4, that is 225. Therefore, the answer here is 225. That's how you deal with the expressions. Again, if you encountered formats wherein there are I here, you just have to expand this in this format. And then I squared, expand that in this format. I3 in the algebraic expression, expand that in this format. Okay, same with others. So for practice exercises, you do not have to submit this on me. You just have to practice on your own, and then we will have a recitation on this next meeting, or on our lecture consultation rather. So that is all for the sigma notation or summation notation.